Hello, this is part 2 of a video I'm calling Properties of the Gamma Function. And let's just jump right in. So number 1, we're going to show that the gamma function is equal to this product. And here's the proof. Now in part 1, we show that gamma of x plus 1 is equal to x times gamma of x. So you subtract 1 each time. Then gamma of x plus 2 would be equal to this. But this piece is equal to that, so we can put it in. And then we just keep going. So gamma of x plus n plus 1, and then you keep doing this recursive pattern, and you get this. And then you divide by this product to the other side, and the result follows. The second one, we want to show that this gamma function is equal to this integral. And then to do that, so I probably should say show this or put a question mark there, but we'll start from here. And we're going to rearrange this a little bit. We're going to multiply by t and multiply by t inverse. So it's like multiplying by 1. Yep, and now we're going to use this substitution. U is equal to t squared, or t is equal to u to the 1/2. du is 2t dt. Substitute this in here, and we get this. But this is the definition of a gamma function. So this is equal to that, which means this is this, because we logically got there, right? Now we're going to use this result in the next bullet point. So point 3, this is for x between 0 and 1. We want to show this result. Gamma of x times gamma of 1 minus x is equal to this, pi over sine of x times pi. Well, let's start with gamma of x and gamma of 1 minus x. So from part 2, this is equal to this, and from part 2 this is equal to this, but we're plugging in 1 minus x right here, which that's why we have 1 minus 2x. So the exponents are a little bit different, but we're just plugging in x to that formula there. Now we combine those integrals to this. The e exponents we can combine. Well, now let's change this to polar coordinates. Let t equal to r cosine of theta, s equal to r sine of theta, and the Jacobian is r dr d theta. So substitute all this in, and we get this. So we substitute in for t, for s, and then this exponent just becomes minus r squared. Now we want to let's rearrange it so we can see it a little bit better. So this, if we take 1 minus this piece, it goes down below. We can kind of keep them over each other. Then the exponents are the same. And then, so it's the sine of theta over cosine of theta raised to this power, which is tangent. And then over here, 0 to infinity, we have r e to the minus r squared dr. Now let's set u equal r squared, so du is dr dr. Substitute it in, and we get this right here. Now the integral of this is minus e to the minus u, and we're integrating from 0 to infinity. Plug in infinity, this goes to 0. Plug in 0, we get 1. But it's minus the minus, and then so that's 1, so it just goes away. Then we're left with this integral. Now this is the part I'm hoping that you guys can help me with. This is an extremely tough integral. Well, at least it was for me. I couldn't quite solve this, but this is the answer. Okay, and then actually it completes the proof if you can show this to this. And if you look on the web and or in books, this is the answer. Often they don't show you how they get there though, and so this is the kind of the proof that I used to get here. Now I'm hoping someone can help me send this to a famous YouTuber to solve and then link this video. And there are now quite a few that are famous, and I don't want to name any because I don't want to miss one. And actually I don't know who is willing to take on this integral to show that this equals this. But that would be great if you could help me out with that. So we're going to consider that proved because I'm assuming that someone's able to prove that. So next, show that gamma of 1/2 is square root of pi. And we showed this in part 1 of properties of gamma function, but we're going to use the previous bullet to prove it. So here, gamma of 1/2 squared is equal to this, but then this fits nicely into this bullet point there, and then we use this result, pi of sine over pi over 2. Sine of pi over 2 is 1, so it's just pi. And then take the square root of both sides, and the result follows. The fourth one, gamma of 1/4 times gamma of 3/4. Well, this fits nicely into bullet point 3, and so that's gamma of 1/4, gamma of 1 minus 1/4, so that's equal to pi divided by the sine of 1/4 pi. And then the bottom here is 1 over square root of 2. Invert, multiply, pi times square root of 2 is what this product equals. All right, well, that's all I have for this video. Hopefully you enjoyed that. I sure did. Please like the video and subscribe so you don't miss the next one. Thanks, bye.